In the beginning of the class, I will show you multiple examples, and I want that you think about the difference between acquired and inherited traits. Which traits are acquired, which traits are inherited, and these I will start with some examples that are very simple. Then I will start trying to show you that this question is not as simple in many cases, and what are the applications. Then I will briefly talk about acquired traits. Then we will talk about Lamarck, and I will show you a video of somebody that describes this topic in detail. And then I will show you a few examples that you need to remember, a few topics that you need to remember for the exams. And at the end, I will talk about the present and the future of these debates between acquired and inherited traits and how they can be affecting our DNA and our chromosome. So let's start. So anytime that we have a phenotypic trait, that we study a phenotypic trait, we know that they can have two origins. One, it could be acquired, or the other one can be inherited. So let me show you an example. Eye color. Here you see different eye coloration. And what do you think? Are those traits acquired or they are inherited? And what about tattoos? Yeah, and what about when you listen to this lecture, you say, okay, he definitely was not born in Canada, so the environment played a key role forming some traits. Yeah, I have an accent, and the environment, as I was born in South America, I have a very particular accent. And I wonder you think about, okay, this seems to very silly what I'm talking about. What about cancer? Is cancer is genetic? And what about, or it could be some environmental factors involved. So this very silly question that we're going to talk about today is actually is still under debate. So now we know, for example, that 10% of the cancers can have an effect can be due to inheritance, so that we inherit a defective gene. So for many type of breast cancer belong to this case. However, the environment also play a key role. So most of the cancer are just that mutations start appearing during our lifetime because we are stressed, because we don't eat well, because we need to work out more. So again, this idea of acquire and inherit traits that we're going to study today has a big implication to our life. So I want you to think about this one. So this person have this tattoo, terrible idea. This one was even worse. And that, poor person. So is this one acquire or inherit? So definitely acquire. And what about this one? I don't know if you noticed something weird in this X-ray. And let me help you. 1, 2, 3, 4, 5, and 6. Is this an acquired trait? Is this inherit? Is this just Photoshop? So this is an inherited trait. And there are people that are born with extra finger, and it's a condition called polydactyly, and it runs in families. So it might also result from genetic mutations. So this is very interesting. So I show you tattoos definitely are acquired, but this one is an example of an inherited trait. And what about this one that looked like science fiction? This is actually an inherited condition. It's a genetic disorder, and this is the name of this syndrome. And the main characteristic is the appearance of facial hair. What about this one? Definitely this one will be acquired. You choose to do these kind of things. And Amanda is blind from a firework accident. Definitely is acquired. So now we have this case, the colors in flowers, and generally this trait is inherited, but in this case, of course, it's an acquired trait. How you do that? You just have a dye here, or a dye from a different color, and as the flowers absorb the dye, they will start changing in color. And if you have multiple dyes, you can have not one color, but you can have multiple colors. And what I wanted to show you is that this problem seems to be more complex than we thought in the beginning. There are cases that the traits are very easy to track if they're inherited, and other ones that are more complicated. And in nature, this happened multiple times. So let me show you several examples. So in this figure, I just want to show you that primates can be albino, and not only primates, other mammals like hedgehogs. In this case, they have a genetic mutation, and they can also be albino. And actually, it's more common in animals like birds, amphibians, and reptiles. So throughout the animal kingdom, you can find this condition. So first thing, remember this. And also, as I said, they are commonly found in birds, reptiles, and amphibians. And in our taxa, like mammals, these two examples that I show you, they are more rare. And I show you that, for example, this is a mutation. And here you can see here the normal one, the normal bird, and here the normal pigmentation. And it's something that seems to be very common. However, although there definitely in those cases there was a genetic component, in our animals you can find a completely different story. So a similar phenotype, but a completely different story that is not genetic. For example, in the case of the flamingos. In the case of the flamingos, the white ones here and the ones that have color, the difference is mainly because of food deficiency. So they usually don't have a genetic basis. So although both, these can be albinos and this one can be white too, these one are just because of food deficiency, while these ones are just a genetic mutation. So the flamingo coloration is fascinating because actually they are born gray, so the feathers have a different color, and gradually they will start turning pink. And the name of the dye is not important. This is not going to be in the exam. What is going to be possibly in the exam is that you know that they actually need, there's an interaction with the environment. So in the diet, they start eating shrimp and blue algae, and this is where they obtain the coloration. So while previously we talked about a genetic component, here we are talking about also an environmental component to change the color of these birds. So as I introduced before, this has an important application, that is what happened during cancer. Is this genetic, or this is environmental, or is both, or is a combination of both? And I want to remind you that cancer is not one disease, it's more than 100 diseases. So that we all call cancer because you see a tissue that starts growing and growing and growing and growing and growing without control. But there are multiple diseases, so there could be multiple mutations involved into that. So some cancers can definitely have a genetic component, where other ones, they can have more environmental. But definitely the only way to know this is to study the mechanisms. Yeah, what happened at the DNA level, what happened at the cellular level, what happened at the protein level. All these levels are very important. And when we know what is the mechanism, we can say to what degree is genetic and to what degree is environmental. So we will talk more in class and I will show you more examples, but definitely we're moving, instead of thinking that it's only genetic or it's only environmental, we're thinking about that there are degrees, that there are cancers that they could be more genetic and more environmental, but both of these components are very important to understand this. So, but the idea is that this topic of that Lamarck started talking about is actually still under debate, and there is a lot of implications to our society. So now let's talk about what are acquired traits. So now we're going to talk about the transmission of acquired traits, and this is the classical example, the giraffe. And here I know that you notice that this giraffe has a short neck, while this one has a long neck. And the question is how this happened. And in this case of inheritance, they do the difference is because they are using and disusing a trait. In this case, they are using a lot their neck, so they are getting longer and longer necks, like in the same way that you're doing in the gym. But in this case, they are, when you work out in the gym, you remember, so the more that you go, the stronger that you get. So they are proposing something very similar. However, they are not only proposing that they start getting longer necks, but the next generation is also getting longer and longer necks. So remember, I talk about this classical example, and we will talk more about that in future slides, of the elongated neck of the giraffe. And the concept basic of this is the use and disuse. I also told you that the giraffe, that they acquire longer necks, they will have offspring. Their kids will have also long necks. So while the parents were born with short necks, the next generation will acquire the experience of their parents, and they will be born with longer necks. So the traits actually change or acquire during the lifetime could be passed down to its offspring, and this is very interesting. And later we will talk how much of this could be applied to our current research, and what is definitely not happening. So, for example, we know that this is not true. The giraffe don't get longer their necks because of this reason, but we will talk more about that in future slides. So the transmission of acquired traits is actually an ancient idea, and it comes even from the Greeks. So, for example, Pythagoras and Aristotle talk about that, but in a different ways. In the case of Pythagoras, if you remember, he was talking about vapors. So during their lifetime, those vapors were absorbed, and during their lifetime, they were getting this experience, and via semen, you were able to transmit these acquired traits to the next generation. In the case of Pythagoras, if you remember, he said, it's not only through the fathers, yeah, you can also, in addition to the transmission to father to son, you can also be to the grandfather and also to the females. But also he thought that acquired traits were important. And every time that you hear this idea of inherit traits, they're attributed to Lamarck. He actually didn't invent it. He didn't develop this idea. They were so popular for centuries that he just continued talking about that. And why they were so popular? Because Darwin wasn't there. Yeah, so they didn't know why some traits persist, what other ones disappear. So they didn't know anything about DNA or genes. So remember, these ideas were very popular because they explain how phenotypic traits persist while other ones disappear. And the mechanism was very clear. Some traits are used and are disused, and in that way you can inherit some of them and other ones don't. And this example was very popular. And this is a silly joke that talk about that. Not a very good joke, but talk about this use and use of traits.